Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. In today's session, I am going to discuss about the Laplace transform of series RL circuit. Okay, so in this Laplace transform of series RL circuit, so we have to find out the total current response of series RL circuit. Okay, and also we have to find out the voltage drop across the resistor and voltage drop across the inductor. Okay, so here, so we need to discuss about the Laplace transform of series RL circuit. So okay, so in this series RL circuit, so first of all we need to draw the circuit here. So here is the series RL circuit. So resistor and inductor. So here we are having the resistor and we are having the inductor. So these two are connected in series across one voltage source. So voltage source is here. So plus minus voltage, resistor and inductor. So it is a total series circuit. In series circuit, the constant term is I. So we have to take in terms of the time domain. So voltage also we have to take in terms of the time domain, that is V of t. So here this is V of t and the current is I of t. So it is a series circuit. In series circuit, current is constant, but we are having the different voltage drops at resistor R and at inductor L. At resistor R, voltage drop is VR, at inductor L, voltage drop is VL. Okay. So now we need to write the voltage equation of the resistor and inductor. So here for the resistor, the voltage equation is VR equal to I of t into R. So Ohm's law, V equal to I into R. So VR is equal to I of t into R. At inductor L, VL, at inductor L, VL is equal to L into d I of t divided by dt is the equation. Okay, so voltage drop across resistor is VR equal to I of t into R, and at L, VL is equal to L into di of t divided by dt. Now it is a one single loop. In the single loop, we have to apply the KVL. So here apply KVL in a given loop. So we'll get plus V of t minus VR minus VL equal to 0, or V of t equal to VR plus VL is the equation. Now substitute these two equations here. So now V of t equal to, so VR is I of t into R plus VL is L into d I of t divided by dt. So we have to substitute VR value and VL value in this given equation. So we'll get I of t into R plus L into d I of t divided by dt. Now for this equation we have to apply the Laplace transformation. Okay, so here Laplace transform of V of t equal to Laplace transform of I of t into R plus Laplace transform of L into d I of t divided by dt. Right. So now, so Laplace transform of V of t is V of s by s equal to Laplace transform of I of t is I of s. R is constant. So R into I of s plus Laplace transform of L into d I of t divided by dt. In that L is constant into, so Laplace transform of d I of t by dt is s into I of s. Now in this equation, take I of s as a common term here. So I of s into R plus Ls. Now we have to find out the current response in terms of the S domain. So I of S equal to V of S by S into 1 divided by R plus Ls. Now this 1 divided by R plus Ls we can write like this, V of S by S divided by, now in this equation take L as a common term here, L into S plus R by L. I am taking the L as a common term. So L into S plus R by L, that is equal to V of S by L into 1 by S into S plus R by L. Now this equation we have to calculate in terms of the partial fraction. Okay. So for this equation the partial fraction is 1 by S into S plus R by L equal to A by S plus B divided by S plus R by L. Right. Now by simplifying this equation we will get A value and B value. After that we can substitute 1 by S plus R by L value in this equation. So here 1 divided by S into S plus R by L, that is equal to, so take LCM, S into S plus R by L into A into S plus R by L plus BS. Now S into S plus R by L, S into S plus R by L get cancelled. Now 1 equal to A into S plus R by L plus BS. Now in this equation, first case I am taking the S equal to minus R by L. Substitute S equal to minus R by L. So we'll get 1 equal to A into minus R by L plus R by L plus B into minus R by L. So R by L get cancelled. So A value is 0. Then B equal to minus L divided by R. So B value. Now substitute S equal to 0 in that given equation. So we'll get 1 equal to A into 0 plus R by L plus B value B into S is 0. Then we'll get A equal to L divided by R. Now substitute this A value and this B value in this equation. Okay. Now I of S equal to V of S. So this is I of S equal to V of S by L into 1 by S into S plus R by L. That is equal to V of S by L into A by S plus B divided by S plus R by L. Okay. So now substitute this A value and B value in this equation. So we'll get I of S equal to, so V of S divided by L into A value L by R. So L divided by R by S plus B value minus L by R divided by S plus R by L. Okay. So now I of S equal to V of S by L into, so here L by R is there and here also L by R is there. Take L by R as a common term here. L by R into 1 by S minus 1 by S plus R by L. Okay, so here L get cancelled. Now I of S equal to V of S divided by R into 1 by S minus 1 divided by S plus R by L. This equation in terms of the S domain. In S domain, the current expression I of S equal to V of S by R into 1 by S minus 1 divided by S plus R by L. Now we have to convert into the time domain. For that, we have to apply the inverse Laplace transformation. Apply inverse Laplace transformation on both sides. So Laplace inverse of I of S equal to Laplace inverse of V of S by R into 1 by S minus 1 by S plus R by L. So Laplace inverse of I of S is I of t equal to, here also V of t by R into, so Laplace inverse of 1 by S is 1 minus Laplace inverse of 1 by S plus R by L is e power minus R by L into t. This is the current expression in terms of time domain. So this is the total current response of the given series RL circuit. So I of t equal to V of t by R into 1 minus e to the power of minus R by L t. Right? Now we have to find out the voltage drop across the resistor and inductor. Now the voltage drop at resistor R, that is VR, equal to I of t into R. That is equal to I of t is V of t divided by R into 1 minus e to the power of minus R by L into t into R. RR get cancelled. Will get VR equal to V of t into 1 minus e power minus R by L into t. This is the voltage drop across the resistor R. VR is equal to V of t into 1 minus e to the power of minus R by L into t. Now for the inductor, so the inductor equation is VL equal to L into di of t divided by dt, that is equal to L into d by dt of I of t, V of t divided by R into 1 minus e power minus R by L into t, that is equal to L into V of t divided by R is constant into, so d by dt of 1 0 minus d by dt of e to the power of minus R by L t, so e to the power of minus R by L into t into d by dt of minus R by L into t is minus R by L, that equal to L into V of t divided by R into e power minus R by L into t into R by L. LR get cancelled. Now VL equal to V of t into e power minus R by L into t. This is voltage drop across the inductor L. Okay. So here is the current expression and voltage expression of the Laplace transformation of series RL circuit. So I of t equal to V of t by R into 1 minus e to the power of minus R by L t, and VR equal to V of t into 1 minus e to the power of minus R by L t, and VL is equal to V of t into e to the power of minus R by L into t. Okay, this is about the Laplace transform of series RL circuit. Okay, so thank you one and all.